What we're going to get started with today is we're going to look at some word problems with right triangle trig. So we're going to get into 13.2 after working on 13.1 the past couple of days. Our first problem should just be a review. We're looking at a right triangle here, AB and ABC. Our legs, they tell us, are 7 and 24. So we can use the Pythagorean theorem to find what our hypotenuse is. It should end up being 25. So they want us to do in this problem is they want us to find the sine, cosine, and tangent of both angle A and angle B. So let's start by writing down our SOHCAHTOA as a reminder here, remembering that sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. So let's start with angle A here. We've got our opposite side. It's going to be 24. It's the side opposite our angle, and 25 is our hypotenuse. So the sine of A is equals 24 over 25. Our adjacent side is 7. And our hypotenuse again is 25, and for tangent we have opposite over adjacent, so our opposite is 24, and our adjacent side is 7. Moving on to angle B here, our fractions are going to change up just a little bit. We have 7 for our opposite from angle B, and 25 for our hypotenuse. For cosine of B, we have 24 as our adjacent, and 25 again is the hypotenuse. And our tangent is going to be 7, our opposite, divided by 24, our adjacent. So there's a quick review about what we've been working on the last couple of days. In this example, they want us to find the length of a hypotenuse of a right triangle. And they give us that the angle measures 20 degrees, and our opposite leg measures 410 feet. So again, this is our opposite leg, and they want us to find the hypotenuse. So we have to think which trig identity we have uses both opposite and our opposite leg and hypotenuse, and that's going to be sine. So sine of 20 is going to equal the opposite side over our hypotenuse. Our opposite side, they tell us, is 410, so sine 20 equals 410 over x, our hypotenuse here. We want to solve this for x, we have to multiply both sides by x. Here our x's are going to cancel. Here we're going to move this down. So we end up with x times the sine of 20 equals 410. Again, we have to continue solving for x, so we have to get the sine of 20 moved over to the other side of our equation. So we're going to divide both sides by sine of 20. These two are going to cancel. We can figure out in our calculator that sine of 20 is 0.342. And when we divide 410 by 3.342, we end up getting 1,198.8 feet. So again, that's the length of our hypotenuse, and we use our sine identity to calculate that. Here we have to find the measure of the angles of A and B and the length of our hypotenuse. So let's start out finding the length of our hypotenuse. We can do Pythagorean theorem here. We have 8 squared plus 15 squared. It's going to equal our c squared. 8 squared is 64, and 15 squared is 225. If we add both those together, we're going to get 289, which equals c squared. And to solve that, we have to take the square root. So our c value is going to be 17 centimeters. Now, to find the measure of the angles, what we're going to do is we're going to look at, first, let's say we want to find angle A here. We're going to use our tangent because we have opposite over adjacent. So we would say tangent of angle A equals 8 over 15. And we can simplify this 8 over 15. Let's write this as a decimal. So tangent of A is approximately 0.533 repeating. Okay? Now, to figure out what this A value is, we have to use our calculators. And what we do is we're going to find that second button, the yellow button on our calculator if we have an TI-83. We're going to push second, and then tangent. And it's going to be that tangent inverse button, where it's got the little to the -1 power there. And if we type in tangent inverse of 0.533, we're going to get our angle. And for angle A, we're going to get this to be 28.07 degrees. And we can run through the same thing with angle B. We just have a different fraction now. The tangent of angle B is going to be our opposite over adjacent, which is going to be 15/8. Now solving this, we get tangent of B equals 1.875. And here's where we use that second tangent button again. So second tangent, to get our tangent inverse of 1.875. And the angle that we get when we have that is 61.93 degrees. Notice both of our angles, angle A and angle B, when added up will equal 90 degrees, which is what we want because we need to have 180 total degrees on our triangle. The next situation we're going to look at a girl standing on the bottom of a hill, and she's going to wave up to her friend who's roasting marshmallows at a campfire on the top of the hill. They tell us that the angle of elevation is 27 degrees, and the girl's 200 feet from the bottom of the hill. So they want us to find how tall the hill is. Before we get into that, we need to get some vocab, because what is this angle of elevation here? We have to figure out what that means. Okay, here's our picture. We've got angle of elevation here, so it's going to be this angle. Here's our girl roasting marshmallows at the campfire. But the definition of angle of elevation is that if we're looking up, it's the angle from the horizontal up to the line of sight. So back to our picture. So from this horizontal line, that goes up. So think about elevation going up to the line of sight. If we move forward, we have angle of depression. So if we're looking down, it's the angle from a horizontal down to the line of sight. So the girl up here roasting marshmallows is looking downwards to her friend. So this is our angle of depression here. So let's go back to this problem and see if we can solve this. So they tell us the angle of elevation is 27 degrees, and the girl is 200 feet from the bottom of the hill. So we got to find how tall this hill is. So we have 27 degrees here for angle of elevation. She's 200 feet from the hill, and we want to figure out how tall that is. So let's set up an equation to solve this. We have opposite side and our adjacent side, so we're going to need to use tangent. So tangent of 27 is going to equal opposite, which is x, over 200. If we multiply both sides by 200 to solve this, we end up getting that x equals 200 times the tangent of 27, which is 0.51. And we get that hill to be 101.9 feet tall. Okay, so similar to what we've been doing, we just add that terminology of angle of elevation and angle of depression. And one more example we have here. We're looking at angle of elevation from a sailboat to the top of a lighthouse on shore. And they tell us that angle of elevation is 16 degrees, and the lighthouse is 121 feet tall. So the nearest foot, how far is the sailboat from the shore? So we're going to draw our picture first, and fortunately, I have a picture in here for you already. Here's our sailboat and our lighthouse, which is 121 feet tall. And we want to solve this using either sine, cosine, or tangent. Our lighthouse is our opposite side. This distance from our lighthouse is going to be the adjacent. So again, we need to use tangent. So tangent of 16 equals opposite, which is 121, over this distance d. Alright, solving for d here, we've got to multiply by d to both sides of our equation. These d's are going to cancel, and we're left with d times the tangent of 16 equals 121. And if we divide both sides by the tangent of 16, we end up getting that d is equal to 422 feet approximately from shore. So again, using that angle of elevation here to figure out this missing distance. And there's your homework assignment.